Our objective today is to subtract fractions including mixed numbers. Subtracting fractions is really easy if you know how to add fractions. You use all the exact same principles. You've got to have the same common denominator, and if you do, all you need to do is subtract the numerators. 5 minus 2 is 3, and we're talking about ninths. If you start with 5 ninths and you take 2 of those away, you end up with 3 ninths. Pretty common sense. In the same way, if you have different denominators, like say you had 5 ninths minus a third, you use the exact same strategies you used for adding fractions. You can't subtract thirds from ninths. They're different size pieces, but you can turn your thirds into ninths pretty easily by multiplying numerator and denominator by 3, which would give us a new fraction of 3 ninths. Now we can subtract our original 5 ninths. There's the bell. We can subtract our 3 ninths from the 5 ninths we started out with. 5 minus 3 is 2, and our common denominator is ninths. So that should be pretty simple review if you already knew how to add fractions. Let's look at mixed numbers, which were a little bit more complicated. We'll start with the simplest case where again we have common denominators. We have two mixed numbers, we're subtracting one from the other. We know how to do 3/4 minus 1/4, and we know how to do 3 minus 1, and that's in fact all we have to do. 3 minus 1 is 2. Now we look at the fractional part. 3/4 minus 1/4 is 2/4, which reduces to 2 1/2. That case is really simple, but what if we had 3 1/4 minus 1 3/4? This is a little more complicated because we only have 1/4 over here, and we need to subtract 3/4. We can't take 3 away from 1. There's two different ways we can approach this problem. I'm going to show you both ways. The first way is to borrow from this whole number. Since we're talking about fourths, if we borrowed from this 3, it would become a 2, and we would add 4/4 to our fractional part. So we just took one of these whole numbers, turned it into a 4/4 because 4/4 is the same as 1, and added it to our fraction. This now becomes 5/4, and now we can subtract this numerator from this numerator. 5 minus 3, 2/4 is my fraction, and now I have 2, because remember I don't have 3 here anymore because I borrowed from it. 2 minus 1 is 1. 1 2/4, which equals 1 1/2. Let's look at a different way of doing this exact same problem. So in the last example, we borrowed from this 3 so that we would have a big enough numerator here to subtract, to do our fraction subtraction. This time we're going to do it differently. We're going to convert these entire fractions into improper fractions, do the subtraction problem, and then we'll probably have to reconvert to a mixed number. Let's take that one step at a time. So to convert 3 1/4 into an improper fraction, you know how to do this. I'll just talk you through the shortcut. 3 times 4 is 12, plus 1 is 13. The improper fraction is 13/4. 1 times 4 is 4, plus 3 is 7, 7/4. Now we can do our 13 minus 7. 6/4 is our final answer, but it's not in simplest form. 6/4 is like 4/4, which is a whole, with 2/4 left over, which is the same as 1/2. And if you recall, that's the exact same answer we got using the other method. If you're doing it right, you better get the same answer using either method. For some kids, it's easier to convert both fractions into improper fractions so you don't have to deal with the borrowing idea. But for some students, borrowing is easier. We'll look at one more example of each, and then you can decide which one you would rather do. Here we have two identical fraction subtraction problems. I'm going to solve the top one using the first method of borrowing. The second one I'm going to solve by changing all of my mixed numbers into improper fractions and then simplifying once I get my answer. So 1/8 minus 3/8, I can't subtract 3 from 1, so I'm going to borrow from my whole number. This becomes a 3. 8/8 would be what that 1 whole that I just borrowed looks like. So I need to add 8/8 to my 1/8. That turns this side of the fraction into 9/8. 9 minus 3 is 6. So I'm going to end up with 6/8, and now I can look at my whole numbers. 3 minus 1 is 2. 2 and 6/8, which reduces to 2. 6 and 8 are both divisible by 2, so I can reduce 6/8 to 3/4. That same problem, but converting both of these fractions into improper fractions. 4 times 8 is 32, plus 1 is 33. So this converts to 33/8. Over here, 1 times 8 is 8, plus 3 is 11. 11/8. Now I don't have any whole numbers at all to deal with, but I have bigger numerators. 33 minus 11, 22/8. So now I've got an improper fraction that I need to turn back into a mixed number. 8 goes into 22, 2 whole times, that would give me 16, and I have 6/8 left over. You should see that this is turning out to be the same as what we got the first time, which is a good sign. Reduces to 2 and 3/4. So which one of those two do you think is easier? Do you think it's easier to borrow just one whole number to give yourself one improper fraction here? Or do you think it's easier to convert both fractions to improper fractions and then do your subtraction and reconvert your answer? Either way you do it is fine, doesn't matter, whichever way you're more comfortable with. So you should have a worksheet that has a few problems that look like this for you to practice on. Choose one of these two methods, do your best, and if you have a hard time with it, just make sure you talk to your teacher about it tomorrow morning. Okay, good luck.